So g of x is an antiderivative of f of x. And then they give you this g of 2 equals -7. So that is your initial condition. So -7 is where we're beginning. This is going to be -7 plus some accumulation. And notice the accumulation doesn't start at 0. Sometimes it does start at 0, but oftentimes it doesn't. It starts at whatever number they tell you. So our accumulation is going to start at 2, and we want to go from 2 to 4. They're asking us for g of 4. So this will be from 2 to 4, f of t dt, and you don't even have to do anything else. That's the answer. They just wanted you to set it up. So it's initial condition plus accumulation. So that one is. And then this next one printed really small. Let me jump over to the other tab and I will read this to us and write the equation a little bit bigger here. Let me just change the zoom. All right, water is pumped into a tank at a rate of, and then they give us this R of T equation equals 30 parenthesis 1 minus e to the power negative 0.16 T, and that is gallons per minute. Again, it's a rate, something per something else. The tank contains 800 gallons of water. I don't know if you can see that there. 800 gallons of water when it's turned on. So that's the initial condition, is the 800. How much water is in the tank at 20 minutes? All right, so again, it's like this one here. It's going to be initial condition plus however much water we've accumulated. So it'll be 800 plus, and then we're going to have an integral for this R of T function. And it said 20 minutes. So we want to go from 0 to 20. So everybody follow along with me as I type this in the calculator. This is a skill you're going to need, and practicing it is important, right? So it is going to be 800 plus, and on the AP exam, they never give you nice functions. They're always like really nasty looking things like this. 800 plus integral 0 to 20, again, because it said after 20 minutes, so 0 to 20. And then I'm going to put this R of T function. So 30 parenthesis 1 minus e to the power negative 0.16. I'm going to, again, put x. I know it's t, but I'm going to put x because that's more convenient. And then dx. And that will literally just give you your answer. All you have to do is set it up and type it in, which is how most of these go. You just set it up and type it in. So that's our answer. 1,220 roughly gallons of water that have been accumulated. So that one is D. All right, number 3. Again, let me jump over to another tab and read this. All right, so number 3 says, the rate, which is what they're usually going to give you, the rate at which motor oil is leaking from an automobile, from a car, no one calls it an automobile anymore, all right, is modeled by the function L, and I'll write this bigger for us. L of T equals 1 plus sine of T squared in liters per hour. Again, it's a rate. That's the rate at which the oil is leaking out. How much oil leaks out during the first half hour? All right, so we're not given an initial condition here. This is just how much oil leaks out in that half hour. So it's 0 to a half L of T dt. And again, we're just going to type that in. So integral 0 to a half. And then in here, I'm going to put that L of T function. So 1 plus sine of x squared, and then dx. And that will literally just give you your answer. So 0.541 liters. Again, this was liters per hour, and then we accumulated liters over that time interval. So 0.541. So that one is D. All right, a function f is defined by, and they give us this square root of x cubed plus 2. G is an antiderivative of f such that, all right, this bigger, g of 3 equals 5. All right, your brain wants to be like initial condition. That's where we're starting. The accumulation starts at 3. We want g of 1. This is what they're asking us for. So it's going to be the initial condition plus the accumulation. So 5 plus, and then again, this didn't start at 0. It can start at whatever number they tell you. So we want to go from 3 to 1 of this f of x function here. And again, we're just going to type it in. Again, initial condition plus accumulation. So 5 plus integral 3 to 1. And then this is square root x cubed plus 2 dx. So negative 1.584. Or they always round up, so it'll be negative 1.585. So that one is B. All right, now number 5 is the weirdest question on here. I made this a bonus question. So if you got them all right except number 5, you still got 100. And if you got question 5 right, I gave you a +1 bonus. I'm actually regretting even giving this one because this question is just so strange. So we're not going to spend a super lot of time on it. This is just a really weird one. The particle is moving along the x-axis so that its acceleration is given by this graph. And that's the weird thing, is that instead of giving you velocity, which is typically what they give you, they gave us acceleration for all values 0 to 1. At time 0, the velocity is -0.5. So that's the initial condition. At time 0, the velocity is -0.5. And the question is, which of the following things must be true? Right, so I'm going to just write a statement for velocity here. I'll call it v of x, because we're going to have an x and a t in here. You're going to start with -0.5. That's the initial condition. And then plus the accumulation. This one is starting at 0. They said at time 0, the velocity is -0.5. So it's going to be from 0 to x. And then the acceleration is what goes in there. And then the acceleration is the graph that you have. A lot of these choices really just don't make much sense. Like letter A says the particle passes through 0. That's talking about position. We don't even have any information about position. C and D are talking about the velocity being negative and positive. Like if I get out my stick-it note here, this would be position, this would be velocity, this would be acceleration. If you're talking about velocity being positive or negative, well, we have the acceleration function, and that really doesn't help us here. So like a lot of these choices, you really just can't, they really just don't make much sense. Again, I'm regretting giving this one. The answer is going to be B. It says the velocity is 0 for some time in between here. If you set this whole thing equal to 0, and sorry, I kind of ran into the edge of the paper there, you would add over this -0.5. That would be +0.5 on the other side. And so at some point in between 0 and 1, this accumulated area is going to be 1/2. If you accumulate area under this graph, it's going to equal 1/2 at some point in here. So that one is B, and just don't think about it too hard. That was a very strange question. Again, I made that one a bonus question. All right, then I like question 6. The only thing I don't like about it is how this graph is drawn. We'll get to that in a second. It's a good question. The graph is just weird. This is the graph of f prime, the derivative. So we're back to normal. That's usually what they give you. They usually give you a rate, a derivative, a velocity. That's typically what you're given. It says f of 0 equals 5. You want to go, oh, initial condition. That's where they're starting us out. We want to find f of 1. That's our question. All right, so it's going to be where you started. 5, the initial condition, plus the accumulation, and it's going to start at 0. We want to go from 0 to 1 of this f prime of x graph. So it's 5 plus, and then we want the area under the curve. All the other ones, we just stuck it in the calculator. This one, you don't have a function to put in the calculator. What we're going to do is find the area of this triangle, which is 1/2 base times height. And here's where I feel like this question is really weird. The base is 1, like that says 0 to 1, and then the height is 6. This is very much not to scale. Like this is 1, and then this distance is 6. 1 and 6 look awfully the same in this question. So that's the only issue I have with this one. Like I like the question, it was a good question, but this is very much not to scale, which throws you off. You know? All right, so anyway, that would be 5 plus 3, which is 8. And so that one is D.